Okay, ecology, we're on to the final core concept on our midterm exam, which is core concept number 5. And this is where we're looking at how the biodiversity of an area is influenced by the area's size, isolation, latitude, and history. I also want to say this is the last one. I'm glad this is the last one I'm recording because the neighbors are starting to gather to wonder who on earth I'm talking to. First one of the learning objectives I asked you to address with core concept number 5 is historical. And I wanted you to notice that people have been trying to study geography. Going all the way back to Humboldt, we're back in, this is Humboldt that the Humboldt Currents is named after. We're back in, oh goodness, what year are we in? The late 1700s, 1799. Right there at the turn of the century, moving into the 1800s. Early on, people were interested in geography in terms of shipping lanes for the beginning of trade. And then this became part of the history that naturalists like Darwin and also Humboldt himself added to shipping expeditions to look at islands where they're located, continental associations to islands, the species that you find in different parts of the world. And it really was the beginning of the study of initially like plant geography, which looks at biome locations around the world based on latitude, as well as what we've learned with corresponding climate. And then with Robert MacArthur coining the definition of geographic ecology, which you gotta love how simple this definition is: search for patterns of plant and animal life that can be put on a map. Okay, that it was kind of, I'd like to know the history actually of why that definition. Of course, why make something complicated when it's not? So that first learning objective, again, is just to kind of put this work in a historical perspective. Explain and evaluate the contributions of Robert MacArthur to the fields of geographic ecology and evolutionary biology. The theory of island biogeography has application in both. Not only are we going to see how area of land and isolation of land influences the number of species in that area, but whenever you start looking at rates of extinction, immigration, speciation, this is used in evolutionary biology. Landscape features that can be considered islands, don't just think oceanic. Think small lakes on the landscape of northern Minnesota. Think mountain peaks at any kind of like high mountain elevations, whether it's in the Smoky Mountains, the Rocky Mountains, the Andes Mountains, whatever mountain range that you want to consider, where you have those unique plant associations at those high elevations of different sizes depending on the elevation of the mountain or the altitude of the mountain. Let's see here. So lots of different features that can be considered as islands. Also, areas, fragments of land within an area that's being considered for conservation, like the activity we did on Thursday, where we looked at an aerial view of the city of Starkville and different areas of town that have remaining patches of forested land. Explain the relationship between biodiversity, species richness, or the number of species in a given area, and island size. So getting into island biogeography. The larger the island, the more niches are available, the higher the species diversity, or the species richness, number of species per island. Smaller the island, fewer number of niches, fewer species, or less species richness, lower number of species on the island. Define immigration and extinction. Immigration is the arrival of a species to an island. It is, by itself, it is going to add species to an island. Extinction is the removal of species from an island. And I ask you to define both of these in terms of the species niche. So with immigration, there is a niche available to hold the immigrating species, whereas with extinction, the niche is lost, so you have the loss of the species from the island. Let's see, describe the history of this research from E.O. Wilson to Robert MacArthur on to Jared Diamond and Dan Simberloff. This one I'll even take back further because I'll bring in a paper whenever we do community ecology. At the time that Wilson and MacArthur began to work on the theory of island biogeography, they were influenced by E.O. Wilson's graduate advisor, which was G. Evelyn Hutchison. And he wrote these papers on why are there so many different species. And it really gave rise to the height of community ecology in the 60s, 70s, into the 80s. And it started to, the theoretical work on this started to decline as global climate change came in to view, if you will. And a lot of the funding for scientific research shifted over to that and larger scale ecosystem processes. So G.E. Hutchison got his students interested in this. Why are there so many species here? And so E.O. Wilson and Robert MacArthur, their contribution to this was the theory of island biogeography. E.O. Wilson, after Robert MacArthur's death, he was the graduate advisor to Jared Diamond. Jared Diamond looked for the existence of this equilibrium point where there is a balance between rates of immigration and rates of extinction. And then with Dan Simberloff looked at the relationship, is it really true that a big island is going to have more species than a small island? So what would happen if we take that big island and make it smaller? Does the number of species decrease? And indeed it did. So Wilson and MacArthur developed the theory of island biogeography. Diamond and Simberloff tested different components of that, as did many other people following the development of this theory. So restate the theory of island biogeography on your own words. Everybody's going to have a different way to do this. You want to recognize that theory of island biogeography predicts a number of species in an area that is at this point of equilibrium or balance between immigration and extinction. And that equilibrium point is going to be influenced by the size of the island as well as the distance of the island from a source of species on a continent or a mainland. Discuss the finding and importance of Jared Diamond's research on species turnover. Again, he investigated the equilibrium point. Discuss the findings and importance of Dan Simberloff's research that manipulated island size. If you take a big island and you reduce it, indeed the number of species goes down. Applied the theory of island biogeography to both real situations, what we did Thursday, where we were looking at real oceanic islands and using theory of island biogeography to predict islands, such as in the Galapagos or off of the coast of Africa with Madagascar, which island would have the greatest number of species or highest immigration and extinction rates. Those are real situations, hypothetical drawings that I would give you like this on a quiz or on an exam. Depict the relationship. Let's see here. I did that. Before we leave it, let's go over this real quick again, where this balance of immigration and extinction is going to be influenced again by island size as well as distance of the island from the mainland. Here with Island 1, it is smaller, but it is closer to the continental area or the mainland, so it's going to have a higher rate of immigration, but also a higher rate of extinction over time, because there are fewer niches available on this island. So as they fill, competition is going to be great. As other species are trying to immigrate, species are going to get kicked out, and that's that species turnover and the change in composition. Whereas this island number 2, it is further away from the mainland, so the rate of immigration is going to be lower. The rate of extinction is also going to be lower because it is a much larger island with more available niches. So therefore, it's going to take a longer time for those niches to fill before that extinction rate is going to start to go up. Alrighty, so from there we go into another way to approach Hutchison's question, why are there so many different species in an area? And that was looking at the latitudinal variation in species, where the number of species increases as you move closer to the equator. And so Brown in '88 summarized all these different hypotheses to explain this pattern that is consistent as you work from the North Pole to the equator or from the South Pole up to the equator. And they go through, time since perturbation, time since disturbance, productivity, environmental heterogeneity, favorableness, differences in species and extinction rates, and just so go through and work with those definitions. And don't memorize them. Associate them with other things that we've studied, like favorableness with climate. As we discussed, the closer you move to the equator, You have a 365-day out of the year growing season. The climate is more favorable for the production of plant material, linking into productivity. And as we discussed on Thursday, the greater amount of productivity and the greater the length of the growing season, the plants will create more heterogeneity. In a tropical rainforest, you have plants on the ground, you have shrubs, and you have 3 layers of tree species. Then you have all those vines that grow up through the layers of vegetation. That's a lot of heterogeneity. Summarize the relationship between land area and climate in the tropics and their influence on biodiversity. There's a lot of land area in equatorial regions, and a lot of it is from Africa. Africa is an enormous continent. And there's a good graph in chapter 22 that depicts that. And then lastly, linking back to something we talked in core concept number 4, looking at, that was core concept number 3, where we were looking at the impacts of agriculture and urbanization on biodiversity. Discuss the evidence for historical influences on regional differences in biodiversity. Areas of the world where humans have inhabited that area for a longer period of time tend to have a lower level of biodiversity, particularly in areas where there has been a history of agriculture and then later urbanization. And so it's again wrapping this back around with the historical influence. The longer you've had humans in that area, the longer you've had, again, activities like urbanization and agriculture, the lower the biodiversity. So with this, I hope these videos help you get prepared for the midterm exam. You should be able to go through your learning objectives and make sure that your answers are corresponding with the information that was available in the chapter, in the online lecture, and how we approached it with the Thursday activities. As always, reach out to me with any questions that you have.